All right. Hello, everybody. Folks are starting to trickle in. We have a lot to cover tonight. Thanks for being here. So I'm going to go ahead and get started. I'm sure more folks are going to trickle in as I do my little introduction here. But if you're maybe if you clicked on a link and you're like, I don't know what this is, which is probably not the case, we're here to talk about heat pumps. And I'm here with Russ King, who's going to be giving the main presentation, and my colleague Julie with the County of Marin. My name is Kellen Damon. I'm with the County of Marin, and let's get it going. So here's our agenda. We're going to do some webinar housekeeping. I'm going to do a little introduction just about the county's perspective on heat pumps, share a little bit about the current energy efficiency and electrification resources that are out there. And then we'll get into the main presentation with Russ and follow that up with a Q&A. So I'm going to pass it to Julie for a quick webinar housekeeping.
Cool. Thanks, Kellen. So tonight's program will be running from 6 to 7 p.m. We'll have time at the end for Q&A. So if you have any questions, please use the Q&A box. Drop your questions in there. And you can also upvote questions from other attendees. All attendee mics and cameras will remain off for this whole presentation. Um, if you have any general comments, please use the chat box. Closed captioning or live transcript is also available, and you can enable that by clicking on the CC icon in your toolbar. And then we will also make this video recording slides and other materials available for you. They will be sent by email to all registered attendees, and they will also be available on our website at County, marincounty.gov/sustainability. And I will turn it back to Kelvin.
Awesome. Thanks, Julie. So a little bit about the Marin County Sustainability Team. We've been around for about 15 years. We work on, promoting sustainability initiatives, a lot of energy efficiency work and electrification work in Marin County. That extends to the cities and towns. So when we develop programs, it's not just for, unincorporated Marin County residents, but really for everybody in Marin. And we have a lot of our resources or all of our resources on our website right here. And we also post on social media from time to time, especially around events like this, public webinars, public events that we're attending and that sort of thing. One of the grants that we work on and what's able to fund this work right now is the Bay Area Regional Energy Network. So our office participates in BayREN, as it's called. For that program and represents Marin. So we're able to basically bring these energy efficiency resources and programs through BayREN, which is great. So I'm going to talk about the county's perspective on heat pumps. Little known fact, the County of Marin, out of our office, we started one of the first rebate programs for electrification in the state and I believe the country. It was called Electrify Marin. We recently ran out of funding for that because it was very successful. I think we served around 1,000 homes with incentive dollars to replace their gas water heaters with heat pump water heaters, gas furnaces with heat pumps for space heating and induction cooking as well. And we also put in some money for when homes needed electrical panel upgrades and that sort of thing. So we've been working on this for a long time. The county does have a climate action plan where we're trying to reduce our community emissions. And one of the reasons we focus on heat pumps is because, as you can see in this pie chart right here, natural gas from the built environment makes up a really big chunk of our emissions. And you'll see right here that electricity has gone down a lot. A lot of that is thanks to MCE, which is the local electricity provider, and they procure more renewable sourced energy or electricity, and they deliver that to their customers. So that's one reason why the emissions for electricity gone down so much. So because of that, we want people to change from their gas appliances to efficient electric appliances. But it's not just about reducing emissions. There's also, pollution. Nitrous oxide is a big, polluter that can cause lung issues. And the NOx emissions from, your home and buildings produce a lot of that type of pollution in the state right here. And I have these links. By the way, I'm going to be sharing all these slides so you can find these links to these sources and papers, as well as links to programs that I'm going to be talking about later. Second reason is energy efficiency. Heat pumps are 2 to 4 times more efficient on a BTU to BTU output than gas furnaces. And water heaters. Russ is going to get into a little bit of that later on. But really, the issue is cost. So they're, mathematically, objectively more efficient than gas furnaces. The issue, though, is, whether or not electricity rates or gas rates are higher or lower, and that's going to fluctuate depending on markets and that sort of thing. So another reason we're pushing people towards heat pumps is functionality. Heat pump water heaters in particular can load shift, so you can actually work with the grid when there's more renewable sources on the grid. You can be running your heat pump water heater to store that energy, and also when electricity rates are cheaper, so that can help your pocketbook as well. And then what we're seeing a lot, especially in recent years with a lot more heat waves, is that people in Marin are actually looking into installing more, AC units than have ever, happened before. So one thing you can do is, electrify your home, change out your gas furnace, put in a heat pump, and that'll also be able to cool your home in the summer, which is great. And then I do want to shout out this the Bay Area Air District is proposing some new rules starting just next year, 2027, January 1st, 2027, which will basically ban the sale and installation of NOx emitting water heaters. And then they're going to move on to furnaces in 29. So what that means is on January 1st, 27, if your existing gas water heater breaks, you will not be able to install it with another gas water heater. And they are working on some exemptions. One of those exemptions does include financial hardship. So I did just want to point that out. So I'm going to go through this quickly. Again, I'm going to be sending folks these slides and this material. But just a quick note on incentive programs for heat pumps. They kind of come and go. We've seen a lot of incentives from the tech statewide program come and go. They kind of last a couple months and then they go away for a while and then they can get refunded. So really what we recommend folks do is to check the rebate program directories. So MCE has a great rebate program directory and the Switches On has one as well. So you can go on there, enter your zip code, enter the project that you're looking to do on your home, and it'll tell you exactly what you qualify for and what's available in your area. The ones that are still available right now, to my knowledge, are the Clean Heat program through the Air District. That's only if you're replacing a wood burning device with the heat pump. And then PG&E's Energy Smart Homes. And that one is for when you're basically doing your entire home, when you're electrifying your entire home. So maybe you have one or two more gas appliances that you can replace. Energy Smart Homes can provide some funding for that. And then MCE has some heat pump water heater incentives as well. I do want to shout this out. If you're just looking to get started and really don't know where to start, Home Intel, which is a PG&E program, is a great resource. It's free. They work with you online and over email, and they basically analyze your electricity bill and make recommendations to you. And they can give you some advice on electrification as well, which is great. Moving on in the same realm of kind of home energy audit programs, Home Energy Score is a great resource too. It's an in-person energy audit done by a local professional. They kind of tell you how efficient your home is compared to other size homes, and it comes with a assessment report on things that they recommend you do to make your home more efficient. There is a new focus on electrification, so assessors will look at your panel. They'll kind of go over what you're able to electrify in your home currently. So that's a good value add as well. Financing programs. Go Green Financing is a statewide financing program that can basically you can finance a new heat pump through Go Green Financing. Habitat for Humanity is also a great resource. Unfortunately, it's currently waitlisted, and it's only for folks that are under 80% area median income, but it is a great deal. Basically, it's a 0% loan that you can pay back over 30 years. I can't think of a better terms for a loan out there. And then just a little bit on this, we recently launched an income-based program through BayREN for energy efficiency improvements. They're looking to add in electrification projects into that as well. That is called the Ease Home program. And the thing you need to know about that is it's basically for folks that are making at or below 120% area median income, which is pretty relatively high for Marin County. For household size of one, it's about $162,000 a year. And they can give you, attic insulation, weatherization, duct sealing, and they're adding in electrification right now. So that's just a table of the different incomes for different programs. And I'm going to pass it on to Russ. Again, I know I went through all that quickly, but I just wanted to highlight some of those programs. And I'm going to be sending out that information. And you can also email me if you saw something. You're like, hey, what was that program again? Feel free to reach out to me. But with that, I wanted to leave enough time for Russ because he's got a lot to cover tonight. So Russ King, please take it away.
Awesome. Thanks, Kellen. Good evening, everyone. Thank you for being here. It's my pleasure to be here to bring this information to you. It's a great topic. This is actually two classes combined together, so I have a lot of slides to go through in a very limited amount of time. So I'm going to go kind of fast, but you will get a PDF copy of all these slides that you're going to see. So let's see. This class is about residential heat pumps for HVAC, which is heating and cooling, space heating, as well as for water heating. And we'll talk about the different kinds of heat pump water heaters and space heating systems. We'll talk about why they're so efficient. We'll talk about the different kinds and all that kind of stuff. So a lot of topics to discuss. Let's do a little introduction, and we'll do some terminology. And then I like to do a little super basic refrigeration cycle description. I think it's very important that people understand why heat pumps are so efficient. This is something we've been doing in air conditioning and refrigeration for a long time. But a lot of people don't really understand exactly how it works and why it's so efficient. We'll talk about advantages for heat pump space heating, the different kinds of heat pumps for space heating. We'll talk about sizing heat pumps. It's very important. That's one of the big disadvantages of heat pumps is they're very susceptible to bad design. All the bad things you've ever heard about heat pumps, those are not a technology problem. Those are a bad design problem. Those were caused by the installer and the designer, not the equipment themselves. We'll talk about advantages of heat pumps for water heating, the different kinds of water heating heat pumps, and then we'll talk about some special considerations. They do require, they are kind of picky about where in a house you put a heat pump water heater, and we'll talk about that. And then hopefully if I don't run too long, we'll have plenty of time at the end for questions and answers. All right. So my name is Russ King. I'm a mechanical engineer. I've been working with the California Energy Code since 1988 and also doing residential mechanical design. My company is Coded Energy. We're the developers of Quick Model 3D. It's a HVAC design software. I've been doing this for a long time, 35 years, going on 36 now. My email is russ@coded.energy. Feel free to ask if you have any questions or anything you want to talk about related to this topic. Contact me there. I have an HVAC blog where I cover a lot of topics related to HVAC and airflow and energy efficiency and stuff like that. And that's russellking.me. And I have a book, HVAC 1.0, Introduction to Residential HVAC Systems. It's a really basic introductory class. It's a book. It's used in several community colleges, construction programs, and things like that. It's a great book for people who need to work around HVAC without actually working on HVAC equipment. So there you go. All right. So HVAC stands for heating, ventilation, and air conditioning. We're going to primarily talk about heating today, okay? The main goal of an HVAC system is to maintain a constant temperature in a house. That's what it is. Well, humans are very fragile creatures. We have to live inside a bubble. and we keep that temperature inside that bubble at a certain temperature because we, for some reason, don't like the outdoor temperature. All right. And we want to do that in an efficient way as possible. All right. Houses lose heat in the winter and they gain heat in the summer. And to maintain a constant temperature inside this bubble, the heater must replace the BTUs that escape, and the air conditioner must remove the BTUs that come in. All right. So think of a house in the wintertime as a bucket of water with holes in it, and we have to keep adding water to that bucket as the water leaks out. As we keep adding water at the same rate that the water's leaking out, we can maintain a constant level. Okay. And sort of the opposite is true in the summertime. The heat's coming in. So a BTU is a British thermal unit. It's about the same amount of heat that's stored in a wooden match. So if you light a match and let it burn all the way down, you've just released 1 BTU. And so if you think about a 80,000 BTU per hour furnace, that means it's putting 80,000 kitchen matches worth of heat into the house in 1 hour. Okay. And that's a lot of kitchen matches. Okay. So this little symbol, the flying kitchen match here, is going to represent BTUs in the following diagrams. Another thing I get asked about a lot is, why do we call them tons? Why are air conditioners come in tons and heat pumps come in tons? Well, it has nothing to do with the weight. All right. Before mechanical refrigeration, people used to buy ice. And they would buy ice by the ton. And so when they invented mechanical refrigeration, the salespeople would come around and say, "Oh, this little unit right here, this can refrigerate as much as 5 tons of ice." And so we would call that a 5-ton refrigeration unit. And that kind of carried over into air conditioning, and it's carried over into heat pumps and stuff like that. And a ton is about 12,000 BTUs per hour. Okay. So when you say a 2-ton air conditioner, that means it can remove 24,000 BTUs or 24,000 kitchen matches worth of heat from the house in an hour. All right. So BTUs per hour is tons. Now, a cooling load on a house. When we look at a house, there's something we can calculate, and that's called the cooling load. And that's the BTUs that are coming into the house, because the BTUs are more concentrated outside the house. Plus, we have BTUs coming in as in the form of sunlight coming into the house, and we can calculate that. We can estimate what that number is, which helps us properly size the equipment that's going to remove those BTUs on those hot days. All right. Then when we cool a house, what we're actually doing is we're removing heat from a house. All right. Don't think of air conditioning as adding coldness. All right. Because that's not what we're doing. We're adding cold air, but we've removed the heat from that air before we put it in the house. So cooling is removing heat from the house. Heating is just the opposite. The BTUs are concentrated inside the house, and they're escaping to the outside through leaks, through holes, through conduction through the walls and conduction through the ceiling and all that kind of stuff. And we can calculate that. If we know the size of the house, we know the geometry of the house, we know the R values of the walls, the floors, the ceilings, we know how leaky the house is, we can estimate that. We come up pretty darn close to a number so that we can properly size the heating equipment that's going to replace those BTUs that are escaping. All right. So that's called the heating load. And then heating, think of heating as adding BTUs to a house, just like the bucket of water that I mentioned. You're adding water because water is escaping, but we want to maintain the constant water level, which is the equivalent of a constant temperature inside of our house. So to maintain a constant temperature in a house, the rate of heat coming in has to equal the rate of heat going out. Okay, very simple. So when we say a equipment is undersized, what that means is the capacity of the equipment, the ability of that equipment to heat or cool, is less than the load of the house, and it basically can't keep up. Okay, as it turns out, and this is what everyone's afraid of. When everyone sizes the equipment for a house, they're afraid that it's going to be too small. All right. Turns out that it's a very rare problem. It is very unusual for the equipment to be too small for the house. All right. And the result is because everyone's afraid to undersize equipment. And if they don't do a good calculation, if they don't do load calcs, or they get lazy and they use rules of thumb, the tendency is to oversize the equipment. All right. So oversize is defined as when the capacity of the equipment, its ability to heat and cool, is much greater than what the house needs. All right. And there's a lot of problems associated with that. All right. And this is a very, very common problem. I would say 90% of homes in the United States, the equipment is way bigger than it needs to be. Okay. And there's a variety of reasons for that, and it causes all kinds of different problems. Um, and if you size it for extreme conditions, just remember extreme conditions only happen about 1% of the time. By definition, when we size an air conditioner to a certain temperature, that temperature only occurs 1% of the time. Well, what about the other 99%? Well, we want the equipment to work at those milder conditions. Okay. We might design to 95 degrees, but we want it to work when it's 88. But if it's oversized for 95, it's going to be way oversized for 88, right? And what happens is something called short cycling. When your equipment is too big, it runs for very short periods of time, basically on, off, like that. It is much better for heating and cooling equipment to run for a long time. And there's a variety of reasons for that. One of the most important reasons is the longer it runs, the better the house mixes up. All that hair in the house gets all mixed up and you get a nice even temperature throughout the house. Okay. But if you blow really hot air into a room and then shut it off, it's going to stratify. The hot air is going to rise and it's not going to mix very well. Another problem is how long would your car last if you just stomped on the gas and hit the brake and stomped on the gas and hit the brake and stomped on the gas and hit the brake? Your car wouldn't last very long. And the same thing goes for heating and cooling equipment. It will definitely shorten the life of your equipment. Okay. So oversizing equipment can cause more comfort complaints than undersizing equipment. But human nature is to worry about the undersizing, right? So HVAC contractors, and very few of them do good load calculations. All right. And I've been trying to get contractors to do load calculations for many, many years, and it's just not in their business model. It's easier for them to just guess. All right. And then deal with the ramifications. And if they just guess, they're going to guess high. And that's not a good thing. And then another thing is I always encourage homeowners, if they're thinking about switching from gas furnace to heat pump, take that opportunity to do improvements to your house, tighten it up, reduce the infiltration of the house, add insulation, change your windows if you're thinking about upgrading your windows, reduce the load of your house so that when you do a load calculation, you can justify putting in much smaller a piece of equipment. Okay. And then you save on your first cost for your equipment. You'll save a lot more on your energy bills as well, and you'll be more comfortable. Okay. So very important. All right. So super basic refrigeration cycle. This is a very complicated topic, and I'm going to keep it as simple as I possibly can. But think of temperature. All right. When you think of the temperature of the air, think of that as density of BTUs. All right. So you're in a room and you've got a fixed amount of BTUs, and that's what determines the temperature. And if you add BTUs to that room, the temperature goes up. Okay. Because the density of BTUs in that space gets greater. All right. So temperature is the density of BTUs, how many BTUs there are in a given volume or a given space, okay, of air. All right. And the other thing, everything has some BTUs in it, even a block of ice. A block of ice has BTUs in it. It just has a lot less BTUs than say a glass of water. Okay. So the more BTUs something has, the warmer it is, okay? But everything has BTUs in it. Even really, really, really cold air has some BTUs in it. And you can capture those BTUs. You can capture those BTUs by making something that's colder than that cold air, and the BTUs are naturally going to want to go into that colder thing, and then BTUs and condense them and turn that substance into a hot, so by compressing it and put that heat into the house or whatever. Okay. So that's where I'm going. All right. So when you remove BTUs at the same rate as they're being added, the house will remain constant. Okay. I mentioned that before, and that's an important concept to understand. So BTUs are coming in the summertime, and we're trying to remove them at the same rate so that the temperature will stay the same. Same thing for heating. All right. Now, BTUs will naturally move from a higher temperature to a lower temperature. This is the second law of thermodynamics, and it's pretty intuitive. And you take a hot block of metal and a cold block of metal, they're the same size. The hot block of metal has a higher density of BTUs. There's more BTUs in it. And when you put those two blocks of metal together, the BTUs are going to want to go from where there's more of them to where there's less of them. BTUs are antisocial. They don't like each other. They want to go where there's less of them. All right. So they're all going to scramble over to the colder block of metal. But then at some point, those two blocks of metals will reach the same temperature. They'll reach equilibrium. All right. And then the BTUs have nowhere to go. It's like, oh, they're the same over there as they're over there. Oh, we just stay where we are. All right. But BTUs will naturally go from where there's more of them, where they're more dense, in other words, where it's a higher temperature, to where it's a lower temperature. That's just what they do. That's just what they want to go. And it's natural. And it's called the second law of thermodynamics. But you can also change the temperature of something if you can change the volume. All right. Now, a block of metal, you can't change the volume, but a room of air or a container of gas, you can change the volume of that and change the temperature because you're making the BTUs more dense. Okay. So that's a very important concept. All right. So if you decrease the volume of something, but leave the number of BTUs the same, the temperature will change. All right. The temperature gets less when you decrease the volume. If you increase the volume and you compress it down, all right, you decrease the volume, you've got a smaller mass or a smaller volume with more BTUs or the same BTUs. So it's going to be a higher temperature because they're more dense. And if you increase the volume, the temperature goes down. If you smush it down and increase the pressure, the temperature goes up. And a good example of that is when they fill scuba tanks. All right. They're taking air and they're smashing it into this small tank, and the air has a certain number of BTUs in it, but they're making that air much smaller, the volume of air smaller. So the tank gets hot. So they have to submerge it in water so the tank doesn't get too hot. Okay. All right. So when you compress a gas without adding any BTUs, it will get hotter. And when you decompress the gas, it'll get colder. So you can change the temperature of a volume of gas by changing the volume. Okay. So now let's look at the temperature inside that tank, that container, and look at the temperature outside the tank. So let's say we have a tank of a gas and we expand it and it gets cold because we've reduced the density of the BTUs. If it gets colder than the outside air, let's say it gets to 40 degrees, but the air around this container is 75, BTUs will come into the tank. It's like a sponge. You expand a sponge and it absorbs water. When you expand this gas, it gets cold and it absorbs BTUs from the air around it. All right. Then the opposite is true. We take it outside or we just smush it back down. All right. And we make it 100 degrees and now the BTUs come out. So we can make BTUs go in and out of this container, changing its volume. All right. Very important concept and critical to the whole process of the refrigeration cycle. All right. Now let's apply that to a house. Let's say we have a house and it's 75 degrees inside the house. And that's what we typically set our air conditioners thermostat to, but it's 90 degrees outside. All right. 75 inside, 90 degrees outside. Now, because it's hotter outside, those BTUs are going to come into the house at a certain rate. All right. But house and we put this container in there and we expand that container and make the inside of that container 40 degrees. Well, the house is 75, but the container's 40. So the BTUs are going to go from the house into the container. All right. So we're absorbing heat inside the house by making this gas a bigger volume. And then we take it outside and we squeeze it and the BTUs leave. If we can squeeze it down to where the temperature inside that container is higher than the temperature outside, we can expel the BTUs. So it's exactly like a sponge. We can go inside the house, absorb the BTUs, take it outside, squeeze them out. Go inside the house, absorb the BTUs, go outside and squeeze them out. And it's all about making that gas colder than the indoor temperature by making it bigger, by expanding it, and making it hotter than the outdoor temperature by squeezing it and making it hotter. Okay. Very important concept. So we have just mechanically moved BTUs in the opposite direction that they want to go. They naturally want to come into the house, but by expanding and compressing this gas, we've moved them outside. All right. That's exactly what air conditioners do. All right. Spoiler alert. We can do the exact same thing in the wintertime when it's colder outside. All right. So let's say it's 30 degrees outside and we want to maintain 70 inside. If we can expand that gas and make it colder than 30 degrees, the outdoor temperature, it will absorb heat. Remember, everything has BTUs in it, even very cold outside air. So it will absorb heat from that outside air. We bring it inside and we squeeze it and make it hotter than 70 degrees, and the BTUs come out. All right, so we can pump them back in the opposite direction, and that's what a heat pump is. A heat pump is basically an air conditioner that runs backwards in the wintertime. Okay, and we can, and remember I said everything has BTUs in it, even 0 degree air. 0 degree air has some BTUs in it, and we can capture those BTUs if we can make that gas colder than 0 degrees. All right. And it's possible. There are refrigerants that you can expand and make them colder than 0 degrees, thereby capturing that heat. And then you bring it inside the house and squeeze it out. Okay. So it's just like a sponge. So instead of using fixed size vessels, like I was talking about this container, we expand it, take it outside, squeeze it, bring it inside. That's kind of tedious, right? To take this container. Someone very clever came up with an idea. Instead of containers, what if you have a continuous loop? And at one part of the loop, the gas is expanding, and at the other part of the loop, the gas is being squeezed. Okay. And so we can move heat by having this loop. So it's like a conveyor belt of these little containers, if you will. All right. And it works quite well. All right. The problem is it's really complicated. I mean, we've been doing this with air conditioning for a long, long time. The house absorbs heat and we dump it to the outside. Okay. If you have an air conditioner in your house and you have a big condenser that sits outside, on a hot day when it's running, put your hand over the top of that condenser and the air is hotter than the outside air. That's the heat that used to be inside your house. Okay. Now we can do the exact same thing by going the opposite direction. So we expand the gas outside, it absorbs heat, we bring it inside and we squeeze it and squeeze the heat out of it. Okay. And it works quite well. But it is more complicated than, say, a gas furnace. A gas furnace is a dumb beast, right? It's just a caveman style of heating. We just burn flame and whoosh, all this heat comes in the house, burn, fire, heat house. Heat pumps are more complicated than that, but they do work quite well. All right. They work very well. But why are they so efficient? Why are they so efficient? If you look at an electric resistance water heater or space heater, okay, anything that you apply a current to and it turns orange and gives off heat, that's called electric resistance. That's 100% efficient, or darn close to it, close enough to be called 100% efficient. Well, how can you get more efficient than 100%? You're taking 5 units of energy, of electricity, and you're running it through an electric resistance heater, and you're getting 5 units of heat out of it. That's 100% efficient. How can you improve on that? All right. Well, you can. Heat pumps cheat. All right. Heat pumps cheat. And the way they cheat is they don't create heat from the electricity that they use. They move heat that's already there. All right. They capture heat that's already been created and they move it from one place to the other through this compressed gas. As it turns out, it takes a lot less energy to do that than it does to create heat, 3 or 4 times more efficient. All right. So you can take 2 units of electricity and capture heat and give you 5, 6, 7 units of heat. All right. So it's 200 to 400% efficient. So that's where it comes into play. Even though gas is or electricity is more expensive, the fact that it's so much more efficient that we can compete with heat in that way. Okay. So that's why heat pumps are so efficient, is they move heat rather than creating heat. All right. So what are some of the advantages to heat pumps for space heating, mainly compared to gas furnaces? Okay. So heat pumps are being successfully installed in some of the coldest regions of the world. I have very good friends in Minnesota and Pennsylvania and some very, very cold climates. They have heat pumps on their house and they love them. They work great. All right. They're ideal for the Bay Area climate. You could not pick a better place in the country to install heat pumps than the Bay Area. We have mild summers and mild winters. Heat pumps are perfect for this climate. Supplementary electric resistance heat, or something called heat strips, all right, is not necessary. You can size a heat pump in the Bay Area that will handle 100% of your heating load. Okay. And you don't need electric resistance strips. All right. But that requires load calculations, that requires a good design. Okay. So some of the big advantages, my personal reason for really promoting heat pumps is the safety aspect. Okay. It boggles my mind. I'm a mechanical engineer. I designed residential heating and cooling systems my entire career, and 99.9% of those were gas furnaces for production homes, big production home builders. And it always just kind of boggled my mind that we had no qualms piping an explosive gas into a house. And then when we use that explosive gas, it turns into a poisonous gas. And then we got to get that out of our house. And it just doesn't make sense to me. Okay. So electricity, heat pumps are electric. There's no explosion danger. There's no carbon monoxide. There's much less fire hazards and things like that. And if you think about it, um, um, this was a quote from a building inspector. The potential for something to go very, very wrong with a gas furnace or a gas water heater is much higher than people realize. This is why CO detectors, carbon monoxide detectors, are required by code when you pretty much do anything to your house. All right. If you go get a permit to even change a sink in your house, they will come and check to make sure you have carbon monoxide detectors. And the reason is the potential for something to go wrong is very, very high. All right. And as we make our homes more energy efficient and we seal them up, that the potential for those gases to get trapped inside our house gets greater and greater. So my theory is that let's just get rid of that gas if we can. Okay. That's my personal feeling. All right. And they're simpler and cheaper to operate, or cheaper to build. All electric homes are cheaper to build than homes with gas. Before the energy code started promoting gas heat because of cost effectiveness, builders wanted to build all electric homes. But the only options back then were heat pumps and electric resistance water heaters, which can't compete with gas. Electric resistance water heaters cannot compete with gas on a cost-effective basis. But now that heat pump water heaters are very common and more available, we can compete. And now the energy code is flipping and going back to discouraging gas and encouraging all electric homes. Okay. So no gas pipes, no flue vents, no combustion air vents, all these other things. Safety issues. Okay. Lower maintenance, combustion appliances must be checked and adjusted regularly. Electric appliance, no gas burner ports to become dirty. No safety devices to fail, no gas condensate to drain or pump out. If you open the panel of your gas furnace and you see all these wires and tubes and everything, 80% of that is for safety reasons. Okay. And if any one of those little tubes gets a hole in it or anything in there gets something's not working, that furnace just says, I'm going to shut down. I'm not going to, it's too dangerous for me to run if I'm not 100% sure everything's working correctly, and it just shuts down. 90% of the calls for furnaces not working is because some safety device has failed and the furnace has decided that it can't turn on. Okay. Very, very common issue. All right. Another advantage of heat pump is now they come in really small sizes. It used to be the smallest heat pump you could get was 1.5 tons. All right. 1.5 tons can work on 1,000 square foot house or even bigger. All right. So what about these ADUs and stuff? A 1.5 ton on an ADU is way, way, way too big. But now you can get heat pumps down into the 1/2 ton range. 1/2 ton, 3/4 ton is more common. And so the equipment is more appropriately sized for small houses and for very, very efficient houses and for zoning houses. So now you can zone a house and have smaller systems around a house and have independent control of those zones. Another one is they're cleaner. No carbon emissions. Obviously, it depends on where your electricity is coming from, but the grid is getting greener and greener every single day. Plus, if you have solar panels on your roof, you basically own your own electric company. Why are you paying the gas company for power, right? You own your own electric company. It'd be like if you own your own, You own your own Toyota dealership. Why would you buy a Nissan, right? You own your own electric company. Why would you buy gas? All right. So it just makes sense. All right. They're super efficient. We talked about that, and they can compete with gas. All right. It depends, like as Kelly mentioned, it does depend on your electric rates and the time of use and all that. It used to be really easy to calculate. It used to be the number was gas was 3 times cheaper than, or 1/3 the cost of electricity. But now electricity with time of use rates and all that other stuff, it's very complicated, but it can compete. It absolutely can compete. Okay. All right, some of the disadvantages. Let's be fair. We talked about the advantages. Let's talk about some of the disadvantages. As I mentioned, heat pumps are much more complicated than gas furnaces. They require more qualified technicians, just like cars have gotten more complicated over the years. Heat pumps are more complicated than a gas furnace, but more are being trained. Contractors, there was a learning curve at the very beginning. There was a big learning curve. It's still there a little bit. There's the controls for heat pumps are very complicated. There was actually a case where some of the mini split heat pumps started in Asia and Japan, and there was a big problem when they translated the installation guides from Japanese to English. There was a mistake, and it was causing installers to not install the stuff correctly. Well, they finally fixed that. That was 8 or 9 years ago, but they can be more difficult to operate by homeowners. They do require a little more conscientious effort of how you operate your thermostat and stuff like that. They require more attention. Okay. But be patient with contractors. They're a lot of this equipment they haven't been installing for very, very long, and they're still kind of getting used to it. But do make sure they do a good design. Do make sure they do a good load calculation. They evaluate your duct system and adjust your duct system to get good airflow if necessary. Heat pumps can be impacted by bad design. All right. All of the problems that you hear about heat pumps, oh, they blow cold air. Well, a heat pump has a supply air temperature of 95 degrees, okay, around 95 degrees. Can you heat a house to 70 degrees using 95-degree air? Absolutely. Absolutely. It's just that homeowners are used to 140-degree air coming out of their registers. But now 95-degree air is coming out of the registers, and they say, oh, it blows cold air. It's not cold, but it's colder than your body temperature. And so it feels cold. If you put your hand over it, because it's colder than your body temperature, it's going to feel cool as opposed to 140-degree air, which is going to feel hot. But you can absolutely heat your house to 70 degrees using 95-degree air. All right. So one of the problems is don't have supply registers that blow directly on people. All right. So they have to have curved blades and shoot it along the ceiling. Where you put them and stuff like that is very important. All right. Load calculations have been required for years, but they've been very poorly enforced. But now that we're doing heat pumps, it's much more important. We're training a lot of building departments how to enforce load calculations and duct design. Okay. It's time contractors start doing what they're supposed to do. If a contractor tries to talk you out of a heat pump system, find another contractor or get a third-party consultant to do load calculations. I think most contractors now have pretty much bought into the fact that if they want to, the heat pumps is a big opportunity for them to get on board but they need to learn how to design them. Okay. Grid reliability issues. More demand on the grid increases potential failures. This is being addressed and it improves every day. But a way to help the problem is to make your house more efficient so that you can put a smaller heat pump on there. Okay. This may require another big problem with heat pumps is they may require upgraded panels, but there's a lot of really cool devices that will prevent you from having to upgrade your panel. They're like load sharing devices that will prioritize, certain, like your dryer and you put your dryer and your EV on the same thing. And if you need to use your dryer, it'll switch over. Okay. There's some really cool opportunities and designs for not having to upgrade your panel. Okay. So I mentioned a bunch of advantages and I mentioned a bunch of disadvantages. If you notice the disadvantages, they're all avoidable. All right. Do a good design, do this, do that, take these necessary steps. They're manageable or they're improving over time, such as the grid. Okay. So as we grow, as we learn, as we improve, things are just getting better and better and better and making heat pumps that much more of a logical choice. All right. So different kinds of heat pumps for space heating. The standard, the old heat pump, the very first house my wife and I bought back in 1990 had a heat pump in it. So 1990, 36 years ago, had a heat pump in it. Okay. Um, they look very similar to a furnace. They have a condenser outside, a big air handler, but the smallest size you could get was 1.5 tons. Now there's a lot what we call mini splits. But do know when most people say mini split, they think of a ductless mini split. They do make ducted mini splits, and I love those. I think ducted mini splits are the way to go. I think ducted or ductless mini splits have a place, but I think they're being over applied, in my personal opinion. You have to be very careful to make sure that they're appropriate for the room that they're in, that they're sized according to the room that they're in, and will that heating and cooling make it to the adjacent rooms that don't have a ductless mini split in them. All right. So ductless can be, they can also be single head or multi-head. So you can have one condenser that handles multiple heads, and those heads, those indoor units, can either be ductless or ducted. So you can do all kinds of combinations of different things. Okay. But again, it's very important to do a good load calculation. You don't want to oversize these. A lot of problems that I'm seeing with ductless systems is because they put too many in a house and they were oversized for the rooms that they were in. And there's all these other issues. Okay. So typical heat pumps most of the heat pumps we talk about are called air source heat pumps. There is something called a water source or a geothermal heat pump. They're not nearly as common, but instead of capturing the BTUs from the air, they capture BTUs from the ground. Okay. They're very efficient, but they're also very expensive, and you need a lot of room. You need a big lot property in order to put them in, but they are out there. If that's an opportunity for you, be sure to look into those as well. Okay, sizing heat pumps. Heat pumps for both heating and cooling provide both heating and cooling from one unit. So that makes it that much more important that you do a good design, that you consider, the ramifications of sizing to the heating or sizing to the cooling. Depending on the climate, the heat pump could be sized fine for cooling, but undersized for heating, or vice versa. Okay, because you've got one piece of equipment that has fixed heating and fixed cooling capacity, and you're applying it to a house where the heating load could be higher or the cooling load could be higher. So you have to be very conscientious about how you do that and make the appropriate choices. The industry standard for designing a system is ACA, Air Conditioning Contractors of America. Manual J is load calculations. Manual S is selecting the appropriate equipment. And Manual D is duct design. And they just came out with a new Manual S in 2023 that has a lot more options for sizing heat pumps. The old way of doing it is you size the heat pump to handle the cooling load. And then you go look at the heating load, go, oh, it's not big enough for the heating load. So you would add electric resistance strips to make up the difference. Well, it shows that in California, we don't need to do that. All right. We can size the heat pump and it will meet the heating load and the heat pump mode only. But then we have to turn and look at the cooling side and make sure that we're not grossly oversized on the air conditioner, depending on the climate. Okay. There's places like Arcata where you have no choice, right? It has a negative cooling load in the summertime. So you size it for heating, but they don't have those oversized issues on air conditioning because they hardly ever use their air conditioner. Okay. So there's those sorts of considerations have to come into play. Heat pumps are working fine in Tahoe and Truckee without supplementary heat strips. And they're not running on the strips. They're working fine. Technology has improved a lot. Heat pumps have gotten much, much better. Low temperature heat pumps will work in very, very cold temperatures. The general recommendation today is to size the heat pump to the larger of the heating or cooling load, and then evaluate the other side and make sure that it's not grossly oversized. Oversized problems can be addressed and reduced by good duct design and good airflow. If you oversize something and then have inadequate airflow, it's going to make the problems that much worse. Another thing is variable capacity. Now it's very common to have a heat pump that has a high speed and low speed, or it can ramp between those two. So if you have a lower load, it can ramp down to behave like a smaller heat pump or air conditioner. Okay. And that can certainly help alleviate some of the oversizing problems as well. Heating setbacks, if a lot of people set their temperature back, okay, generally not needed for heat pumps, okay? But if you do, you have to allow yourself more time to recover. All right. If you like your house to be colder when you're sleeping and then heat up right before you wake up, Well, give it more time to recover with a heat pump. Okay. One of the most common problems with new heat pump system is that homeowners installers are not familiar with the controls. Um, they sometimes have to come back and twiddle with things and fix things. So be patient with them until they gain experience on that stuff. Okay. All right. Let's talk about heat pump water heaters. So heat pump water heaters, um, common characteristics, they come in 40 to 80 gallons, larger sizes available for multifamily. When they're running in heat pump mode, they're pulling about 1.3 watts, about what a blow dryer gives you. But when they kick into electric resistance, they're pulling a lot more than that, 4 or 5,000 watts. All right. So they will run in both modes, but we want them to run as much in the heat pump mode as possible. All the major manufacturers pretty much of water heaters nowadays pretty much make heat pump water heaters. So there's lots and lots of choices out there to choose from. There's two basic kinds. We have integrated, where the heat pump and the tank are all one unit. That's probably by far the most common. But you can also get one called a split heat pump water heater, where the heat pump portion is separate, and you can put that outside, and then you can put the tank, the storage tank, pretty much anywhere you want to inside the house. Okay, quite a bit more expensive, but very, very efficient. Okay. Um, some of the features, there's a heat pump on top. There's usually some special controls. You're going to see some air venting. All right, that's a good indication that it's a heat pump water heater. The bottom portion looks just like an electrical resistance water heater. It's going to have these electric resistance elements in it. It's a large storage tank. It's going to have some sort of electrical connection to it, but no gas. All right. On split systems, like I said, the little thing sits outside and it's going to be connected. Some of them are connected by refrigerant lines, and some of them are connected by a water line. Okay, but they have to be connected to each other. So this can sit outside, and this can be pretty much anywhere you want it inside the house. No heat pump on the top because it's separate. All right. And then electric resistance, there's no heat pump on top. You'll see these two electric resistance heaters. So the main difference is that the heat pump it doesn't have a heat pump. It just runs purely on electric resistance. Um, gas water heaters will have a vent. Okay, that's the giveaway for a gas water heater. Okay, they'll have some sort of controls, mechanical controls. There'll be a gas line coming into it. There'll be a little port to light pilot lights and stuff like that on it. Okay, get through that. Okay, so what are the advantages of heat pumps for water heating? Basically, all the same thing we talked about for space heating. They're safer, no explosion, no carbon monoxide poisoning issues and things like that. They're simpler and cheaper installation. All right, you just set them there and plug them in. Okay, plumb them in, plug them in. Um, they're lower maintenance, except that there is an air filter. All right, heat pump water heaters have an air filter that has to be checked every now and then and cleaned out. All right, their energy consumption is cleaner. They're not burning gas. They're super efficient. Okay, 300 plus percent efficiency. They can keep up and compete with gas on a cost effectiveness basis. And some of them have pretty cool controls. You can control your heat pump from your phone. And it's really funny. I have some friends that just bought a brand new heat pump water heater, and they're looking at their phone going, "Oh, my water heater just turned on. There's nobody home. I think I'll turn it down a little bit." Or, "Oh, I've got company coming over for the weekend to spend the night. I better turn the water heater up," and they can do that on their phone. I think that's very, very cool. They are cost effective, as I mentioned. The disadvantages, the equipment's more complicated. There is a refrigerant and compressor inside there. And so the technician working on them has to be certified to work on systems with refrigerant. So sometimes HVAC contractors are getting in the business of servicing heat pump water heaters. A straight plumber that doesn't have the EPA 608 certification for refrigerants can do all the plumbing and the electrical and hook up all that stuff, but they can't open it up and service the refrigerant part. The controls are more complicated, but when they're on your phone, they're kind of fun to play with. So it's kind of a trade-off there. All right. Grid reliability issues, we talked about that. May require upgraded electrical panel. We talked about that. There are some pretty cool technologies out there. And again, all the disadvantages of heat pumps are avoidable or they're improving over time. All right. So things are just getting better and better to have heat pumps. Some special considerations. The electrical panel, I mentioned that. So if you have a gas water heater and you go into a heat pump water heater, you have to look at your electric panel. But there's some pretty cool circuit sharing devices out there that I mentioned that give priority to certain things. And by incorporating that into your system, you may not have to upgrade your panel. All right. So definitely look into that. Ventilation, heat pump water heaters collect heat from the air and the space that they're in. So they're pulling in air, they're extracting the BTUs from it, and they're blowing out cold air. So a byproduct of a heat pump water heater is cold air. So be aware of that. Uh, Garages are a great place for heat pump water heaters. You can put them in your house, all right, but do be aware that they're going to blow out cold air. So you obviously don't want to put those, near a bedroom or anything like that. But a laundry room or a utility closet or something like that's okay. But if you put them in a confined space, that space needs ventilation. All right. It needs a good source of warm air that it can extract that heat from. They do make heat pumps that are ducted, so they can pull their warm air from anywhere in the house and then extract the heat from it and then blow that cold air anywhere you want. Okay. So that's a pretty cool design for some of them. But most of them they get heat from the room that they're located in or the garage. They do take longer to recover. So if you have, a bunch of people over and you take a bunch of showers and you deplete your water heater tank, it does take longer to recover. So it is generally recommended that if you replace a gas water heater, you replace it with a larger heat pump water heater. Okay. Controls are more complicated. Set the controls per manufacturer's instructions. A lot of them come preset to run to kick into electric resistance heat sooner than you really need to. So a lot of times what they recommend is put it on the economy mode, and then if it doesn't seem to keep up with your demand, then turn it to another a mode that will kick into electric resistance heat if you need it. Okay. Avoid using modes that use energy needlessly. All right. So try to run it as much as possible on heat pump mode. But like I said, a lot of them come pre-programmed to basically provide lots of hot water. Okay. And so you can cut back on that and then kind of fine tune what you think you need. All right. And then adjust accordingly. All right. Bayrin has this wonderful residential water heater replacement permit guide. Kelly can certainly put you in contact with that. You can go to the Bayrin website and find it as well. So if you're in the process of replacing a heat pump water heater, this walks you through the process. It helps you apply for your permit and make that process more smoothly. All right, that is it. I'm sorry I didn't only left you a couple minutes to ask questions. So what kind of questions do we got here?
Yeah, yeah, maybe we'll go a couple over just so we can get everybody's questions
Yep, no
answered.
problem.
I'm going to share my screen again. So before we get started with that, I just want to point out if people want to come and talk to like a heat pump installer, working in HVAC or plumbing. The city of Novato is hosting a Clean Energy Expo on Saturday, May 16th on the City Hall lawn. I think it's their second year of doing that now. It's a pretty cool event. You can come out, get some food, hang out. There's prizes and stuff like that. Also, we do these anyway, these webinars for folks, but it just so happened that it was during Heat Pump Week, if you can believe it. And Heat Pump Week is run by a group called the Building Decarb Coalition. And they asked us to send out a survey here. So if you respond to the survey, you have a chance to win $100 to $1,000. So I thought I would pass that along. I'm going to put that link into the chat right now. And here's that survey link. And then, yeah, Russ, I've been clocking the Q&A. So there's here's a kind of a related question from anonymous attendee. More complicated equipment equals more likely to break down, question mark. Appliances used to last for decades. Now they last for the duration of the warranty. My water heater is very old, but it's very reliable. I don't want to buy something new. It has to be serviced or replaced every 5 years or so. What do you suggest? Same thing with space heaters.
Yeah, they are more complicated. It's kind of the nature of things. Even if you weren't switching to heat pumps, new furnaces aren't as reliable as old furnaces. So, sticking with the furnace isn't going to necessarily that issue for you. But yeah, it's an issue. It's definitely an issue. My suggestion would be to do your research, find out which brands and which models seem to have the best life. There's a lot of consumer reports type Facebook groups and things like that that you can go on. Talk to as many installers as you can, because a lot of installers will have one or two brands that they like to put in, so they're going to promote those brands, right? But if you talk to a bunch of installers, you can hear from multiple people, or attend some of the workshops and things that they talk about, where the contractors show up to those and talk to them. But it is an issue. But like I said, it's the same things with cars. You could buy a new car, you can buy an old car. It's just kind of how the world's going these days. It's getting more complicated.
Yeah, here's one from Bernard, and he has a question about oh, where did that go? About kind of like single units without an outside compressor unit for space cooling, I believe. Actually, I think they make those for space heating as well. But just those, maybe those like window
Yeah,
heat
that's
pump
called a P.
units.
It's called a PTEC, package
Hmm.
terminal air conditioner or heat pump. It's similar to what you would see in, say, like a hotel room, under the window of a hotel room. It's all one unit. Half is outside the house and half is inside the house. They make things like that. They do make window units for heat pump and air conditioning and things like that. So you don't necessarily need a giant condenser outside. But the smaller mini splits, the condensers are not much bigger than a briefcase. They're pretty small, and they stand up, and so you can move them closer to the house. You might see photos of apartment buildings where they're all mounted on the outside of the apartment building, just kind of hanging on the walls. So they take up a lot less space than they used to.
Great. Let's switch to one about what are the pros and cons between tankless water heaters and heat pump water heaters? I like this one.
So first of all, gas versus electric. So we talked about that. If you've got gas in your house, you have all the issues associated with gas and carbon monoxide and fire danger and all that stuff. So beyond that, um, tankless water heaters are on demand, right? So cold water comes in, hot water comes out. The nice thing about them and their big benefit is you're not keeping a tank of water hot all day, even when you're gone from your house. Okay, on a storage water heater, you're keeping that water at a certain temperature. It's your water heater's coming on even when you're not home, okay, because it's maintaining this big tank of water. But a tankless water heater doesn't do that. But the problem with tankless water heater is you need a bigger gas line coming into it, because when it is running, it's using a lot of power. Okay, because it takes a lot of heat to make cold water turn hot all of a sudden. Okay, and so there's some efficiency issues with that, and there's capacity issues as well. You can only take so many showers. You can't have more than two people taking a shower at the same time. Even sometimes two people with a tankless water heater won't provide enough hot water. So it may run out of hot water, not over time, but in demand. All right. Whereas a tank water heater, you can have five people taking a shower, but it will eventually, the tank will run out. Okay. So it's just kind of a different approach. Tankless water heaters are great for like vacation homes and Airbnbs and stuff like that may be unoccupied for long periods of time. That's a big advantage of tank. But to me, the big issue is gas versus electric, honestly. So
Great. We've had a couple questions about price differences between kind of heat pumps and traditional furnaces
mhm.
and water heaters. I know that I think one of the big issues with heat pump water heaters that we've seen is they can range between, $4,000 to $8,000, where just replacing your normal tank water heater is maybe like an $900,000 affair. So there is, quite a big jump in price, at least what we've seen through the rebate program and looking at invoices. That's kind of why these rebate programs have been around. But we do see that with more, contractors coming into the market, the prices are coming down a little bit. But Russ, I don't know if you have anything to add, especially for space heating.
for space heating, it depends. If you're building a new house, it's actually cheaper to install a heat pump because you don't have to run gas to the house. You don't have to run vents and combustion air and all this other stuff. But if you're replacing a heat pump with or replacing a furnace with a heat pump, the equipment is generally more expensive, but not hugely, not like water heaters. A water heater heat pump is substantially more expensive than a gas heat pump, but a heat pump space heating, um, and and you can also just replace your condenser, leave your furnace as your air handler, and just replace your condenser. And then you have what's called a dual fuel system. So you don't have to replace the furnace with a new air handler. You just replace the condenser. There's actually some talk about no longer allowing the sale of heat pump only condensers because the cost difference between a heat pump or sorry, an AC only condenser and a heat pump, the only difference is the heat pump has this little three-way switch inside of it. So if you're going to put on a condenser, why not just if it's the cost difference not very much, just put a heat pump condenser on your house, and eventually you can easily switch over to heat pump because the condenser is already the right kind. So, yeah, it's kind of interesting some of the things they're talking about.
I like this question. This is a very Russ question. We live in a
Mhm.
coastal environment and don't have need for AC. We've been told that our ducts are too small to install a heat pump. Not sure if that's accurate. We have a 2,400 square foot home. What are our options for heat pump installation?
Yes, so if your ducts were sized for heating only for just a furnace, furnaces run on a much lower fan speed than if it had air conditioning with it. So there is a good chance that your ducts are undersized. There's a very good chance your ducts are undersized anyways. The vast majority of homes, the equipment is oversized and the ducts are undersized. So no matter where you live, you should have your ducts evaluated, and it's pretty straightforward process to evaluate your ducts. Um, and it depending on how your ducts are laid out, it may not be that difficult to upgrade your ducts. You can always upgrade on the return side, put on a bigger filter grill, bigger return ducts. That will make a big difference. So it is very possible that your ducts are undersized, but I'm telling you, that's a very common problem no matter where you live. Um, but you can modify your ducts. You can do some work on your duct system without too much effort. If you're in a two-story house, the duct serving the first floor are usually kind of hard to get to, but there's also things you can do related to the type of supply registers. You can change out your supply registers and get more airflow out of those as well. I put my email. Someone was asking how to get a hold of me. I put my email in there. Let me also put I have a blog, russellking.me, and I think I spelled that right. And I have an article about how to evaluate your ducts. And I have an article about simple DIY ways to improve airflow in your system. So yeah, you definitely it is important that you consider your ducts when switching from a gas furnace to a heat pump.
Awesome. Here's another question. Should installers test our duct system's total external static pressure, TESP, before recommending a
Mhm.
replacement system?
Yes, that is something they should always check. And as I mentioned, undersized ducts is a very common problem. And one of the ways to check that is by taking a pressure reading right at the outlet side of your air handler, which is a furnace typically, and right at the inside. So it's going to be a negative number and a positive number. You get rid of the negative sign, you add those two numbers together, and that total number is a good indication of whether your ducts are properly sized. And if it's too high, what it means is the air handler is working against too much pressure, there's too much resistance, and the airflow goes down. So that is absolutely something that should be checked. There's other ways to measure airflow with a flow hood or something like that. It'll tell you about the same thing, but that's a really simple test to do to determine if your ducts are properly sized or not.
Great. Here's another one for D, and we just have like two more. Can a ducted system be zoned, for example, by closing vents or by other means?
Yes, there's something called zone dampers, motorized zone dampers. Um, I'm not a huge fan of it unless you have a really big house or sometimes a two-story house. And what it is just it's dampers that are controlled. You have two thermostats in the house, and when part of the house is calling, the other part closes, and air will only blow to that part of the house. So it's a motorized damper system, is a zone system. Um, I much prefer two separate systems to zone. You have redundancy, and if one system breaks down, you still have another one that can at least heat and cool half your house until you get the other one fixed. And then the other problem with these zone dampers is the ducts are always undersized for those, because when one closes, you're trying to push all of your air through half of your duct system, and you get noise issues, you get static pressure issues, and all these other stuff. So contractors rarely design those well. So if you do decide to go with a zone damper system, I recommend finding a really good designer to help you design that.
Great. And then Don had a question about the price, which we kind of touched on, but one part that I left out was it sounds like the user experience does not accommodate the instant gratification given by traditional solution. Have there been any remedies for that? I'm assuming that's just about the temperature of the air that comes out of the register.
Yeah, and it's, if you were to imagine the perfect HVAC system in your house, it's going to be one that you don't think about, right? And the problem is with furnaces and air conditioners, people have gotten the habit of turning it on and making sure it was working, like putting your hand over the register and go, oh, okay, there's hot air coming out. Well, what if you had a heating and cooling system that just worked, and it was just always the temperature that it was supposed to be, and you never worried about whether it was turned on or turned off? That's what a heat pump is more like than a gas furnace. Okay. So it's a more steady, it's a more level, it's just kind of there, it's just kind of heating stuff up. I think people have gotten, like I like my grandmother had a floor furnace, and we always remember you get up in the morning, it's freezing cold, and you wanted to stand on top of the floor furnace and get that hot air to go up into your pajamas and stuff like that. Well, what if your house was just comfortable and you didn't have to do that kind of stuff? That's what we're shooting for when we design a heat pump system. So yeah, it's a different mentality. It really is. But I think it's one that we can get used to after a while.
Yeah, and one thing I usually add to the introduction of these webinars is just a conversation about, the importance of insulation and air sealing in your home and how, that all works together with your HVAC system. And, it really benefits to think of your house as an energy system. And so if you have a really drafty, uninsulated house, your HVAC system is going to have to be working a lot. And so it's just that's just another part of the equation. Um, and let's see, I think we just have one more. So Karen had a question about point of use water heaters. So we talked about instant water heaters. I do want to, I just remember they have these things where it's like a little maybe 1 gallon device that sits under the kitchen maybe or a bathroom that can be plugged in. It doesn't use too much energy, but it's just a way to kind of have that instant water heater or the instant heated water to where you need it. So your water heater isn't having to pump water throughout the house to get to your faucet.
Yeah, those have a place. I certainly wouldn't run a shower off of those, but they're
Right.
fine for, they're fine for a sink or something like that. They're electric resistance. They don't make a heat pump water heater that
Right.
behaves like that, a small heat pump water heater. So they're going to be electric resistant. So they are going to be more expensive to use. But the balance is it cheaper to put it under the sink, which may be a long ways from the water heater, and you're losing heat by the time it gets there, or you're wasting heat. So there are times where it is more efficient to have a point of use water heater there. Another thing is, I know the energy code will even allow those if you build a really small ADU. I think it's under 500 square feet or something like that. They found those to be cost effective for very small dwelling units. So they have their place, but they are electric resistance too.
Great. I think we can do one more and then call it a night. Let everybody get to their dinner and all that stuff. Is a hydronic heating system electric or gas powered? Can they make heat pump water heating for hydronic systems?
Yeah, they can, but you have to make sure that the heat pump water heater is designed for that. And there was a long time where they weren't. Heat pump water heaters don't like warm water coming back to them that much. they don't work as well. They work better if cold water is coming into them and hot water is coming out. So they had to modify the designs of some of. Plus, you want to account for the fact that now your water heater is doing double duty. Not only is it heating water, it's also heating the space. So you have to have a bigger heat pump water heater to handle that. So yeah, it is possible. It is possible, but it requires very careful design to do that. Yeah.
Great. Cool. Well, I think with that, we'll end it. Thanks again for those that are still here for spending a little bit of extra time. Thanks for coming tonight. Again, I will be sending out the materials, slides, Word doc with links to rebate programs and other programs that you can take advantage of, as long as well as my contact if you have any questions about anything you heard tonight. Thanks again, and everybody have a great night. And thank you, Russ.
Thank you. Thanks, everyone.
And thank you, Julie.